Today we are going to solve a question paper of Cambridge International AS and A level. This is a chemistry paper 1 multiple choice, May-June 2023 series. So let's get started. The first MCQs we have is when chlorine gas is analyzed in a mass spectrometer. Chlorine positive 35 ions are detected. Which row is correct? These are the number of neutrons and these are electronic configuration of chlorine. So let's solve this problem step by step. We are dealing with the chlorine isotope. We need to determine the correct number of neutrons and the electronic configuration of chlorine 35. So step 1 is to determine the number of neutrons. Here the atomic number of chlorine is 17, means chlorine has 17 protons. So the mass number is 35. Atomic number is 17, mass number is 35. So number of neutron comes out to be A minus Z. So N equals 35 minus 17. The answer comes out to be 18. So the number of neutrons are 18. This is the first part. So the second step is the electronic configuration of chlorine 35. As we see that the electronic configuration of chlorine 17 is 1s2, 2s2, 2p6, 3s2, 3p5. This is the electronic configuration of chlorine 35, which have 17 electrons. So now this is chlorine positive ion. Since it has one positive charge, it loses one electron. So the number of electrons in chlorine 35 is 16. So the electronic configuration of chlorine 35 comes out to be 1s2, 2s2, 2p6, 3s2, 3p4. This is the correct electronic configuration. So from given options, we have option C as correct answer, as it has 18 electrons and this is the electronic configuration. The second MCQ states that which species is a free radical. We have 4 given options. From these 4 given options, let's first analyze what is free radical. A free radical is a species that has unpaired electrons, making it highly reactive. In most atoms, electrons are found in pairs. If an atom or ion has an unpaired electron, it is considered as free radical. So let's analyze all these 4 options. Option 1 is helium. The electronic configuration of helium is 1s2. Helium has 2 electrons in its only shell and both are paired. Therefore, helium is not a free radical. This is not a free radical. The second option we have is beryllium. The atomic number of beryllium is 4. So neutral beryllium has 4 electrons. It has electronic configuration 1s2, 2s2. This option shows that it gains 1 electron, making it 5 electrons. So the new electronic configuration becomes 2p1. 1s2, 2s2, 2p1. The additional electron is unpaired in the 2p orbital, making beryllium a free radical. So this is a free radical. Now let's analyze the third option. The atomic number of oxygen is 8. So neutral oxygen has 8 electrons. Oxygen gains 2 additional electrons as it's showing -2 electrons. So this is an oxide ion, superoxide ion. It gains 2 additional electrons, making it 10 electrons. So its electronic configuration becomes 1s2, 2s2, 2p6. All electrons are paired, so oxide ion is not a free radical. The fourth option is zinc. The atomic number of zinc is 30. The electronic configuration of zinc is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. All electrons are paired, so Zn is also not a free radical. The only species that has an unpaired electron is beryllium ion, so this is a free radical. So the correct answer is beryllium ion. This is the correct answer. The third MCQ states that which statement is correct. We are given 4 statements. The option 1 states that first ionization energy of chlorine is more than the first ionization energy of argon. Chlorine has an atomic number of 70, while argon has atomic number of 18. Argon is a noble gas, which means it has a fully filled stable electronic configuration. Therefore, its first ionization energy is higher than chlorine. So this statement is incorrect. Second statement is the second ionization energy of calcium is more than the second ionization energy of magnesium. Calcium and magnesium are both in group 2. After the first electron is removed, magnesium has an configuration similar to neon, which is unstable. Thus, the second ionization energy of magnesium is relatively high. The second ionization energy of calcium involves removing the electron from a less stable electron configuration compared to magnesium. So this statement is also incorrect. Third statement is the second ionization energy of sulfur is equal to the first ionization energy of phosphorus. As we know that sulfur has an atomic number of 16 and phosphorus has an atomic number of 15. The second ionization energy of sulfur is the energy required to remove second electron from the sulfur ion, while the first ionization energy of phosphorus involves removing the one electron from neutral atom. There is no reason for these values to be equal. They are different elements and they have different electron configuration. So this statement is also incorrect. Now the fourth statement is the eighth ionization energy of chlorine is more than the first ionization energy of neon. Chlorine has 17 electrons and the eighth ionization energy means removing an electron that is closer to the nucleus from the more stable inner shell. Neon has 10 electrons and its first ionization energy is relatively high because it is noble gas. However, the eighth ionization energy of chlorine is much higher because it involves removing an electron from the more strongly attracted inner shell, which requires a lot of energy compared to that of first ionization energy of neon. So this statement is correct. So this is the right option. Option D. Now the next MCQ is, if 1 mole of hexane combusts in an excess of oxygen, how many moles of products are formed? We are given 4 options. First, the balanced chemical equation of combustion of hexane is as shown on the screen. Now, the carbon, there are 6 carbon atoms in hexane. So, we need 6 carbon dioxide molecules to balance the carbon atoms. There are 14 hydrogen atoms in hexane, so we need 7 water molecules to balance the hydrogen atom. The carbon dioxide molecules are 6, water molecules are 7. So the total moles of the products are 6 plus 7 equals 13 moles. So the option C is the correct one. The next MCQ states that separate samples each of mass 1 gram of the compound listed are treated with an excess of dilute acid. Which compound releases the largest amount of carbon dioxide gas? We have 4 different options. To determine which compound releases the largest amount of carbon dioxide gas, we need to calculate the moles of carbonate in each sample. The moles of carbon dioxide gas released will be directly proportional to the moles of carbonate used, since all carbonates react in a similar fashion with acids to produce carbon dioxide gas. Now calculate the moles of each 1 gram sample. We have moles of calcium carbonate, lithium carbonate, magnesium carbonate and sodium carbonate. Since lithium carbonate has highest number of moles, it will releases the largest amount of carbon dioxide gas. Hence the answer B is correct. 1 gram of lithium carbonate. The next MCQ states that which statement about the chlorine nitrogen oxide molecule is correct. We have 4 options. Option 1, each molecule contains 1 sigma and 2 pi bonds. This is incorrect. The molecule contains 1 sigma and 1 pi bond, not 2 pi bonds. 1 sigma bond exists between chlorine and nitrogen. 1 sigma and 1 pi bond exists between nitrogen and oxygen. So option A is incorrect. Option B, it is a non-polar molecule. Well, chlorine nitrogen oxide is a polar molecule due to the difference in electronegativity between chlorine, nitrogen and oxygen, making it polar. So this option is also wrong. Option C, it is a linear molecule. Well, the molecule is not strictly linear. Nitrogen in sp2 hybridization creates a bent structure around the nitrogen-oxygen bond. So option C is also wrong. Option D, the nitrogen atom is sp2 hybridized. This is correct. In chlorine nitrogen oxide, nitrogen forms a double bond with oxygen and a single bond with chlorine. For nitrogen to accommodate these bonds, it undergoes sp2 hybridization, which include 1 sigma bond with chlorine and 1 sigma and 1 pi bond with oxygen. So option D is correct answer. The next MCQ states that which row is correct. We are given a table and 4 options. We have carbon dioxide gas, boron trifluoride, ammonia and phosphorus pentafluoride. So let's analyze all these options to conclude the correct option. First we have is carbon dioxide gas. As carbon dioxide gas is linear and have two total number of pairs of electrons in the valence shell of the central atom. Shape is linear, that's correct, and the two number of electrons in the valence shell of the central atom, that's also correct. The information given in this row is correct. Let's analyze the option B. Option B is boron trifluoride. The shape is trigonal planar, that's correct, and it has 3 electrons in the valence shell of the central atom. As we see that boron trifluoride forms 3 bonds with fluorine atoms. There are 3 bonding pairs and no lone pair around boron, giving it a trigonal planar geometry and 3 regions of electron density. Therefore, the information provided in this row is also correct. The next option we have is ammonia. The shape of ammonia is regular tetrahedral. Well, it's wrong. The shape of ammonia is trigonal pyramidal. The total number of electron pairs of electrons in the valence shell of the central atoms in ammonia are 4. Nitrogen in ammonia has 3 bonding pairs and 1 lone pair of electrons. This gives a total of 4 pairs of electrons, but the molecular shape is trigonal pyramidal. So this option is wrong. So this is incorrect. Let's analyze the option D, phosphorus pentafluoride. The shape of phosphorus pentafluoride given is octahedral. Well, the actual shape is trigonal bipyramidal. So this is incorrect. And the total number of pairs of electron in the valence shell of the central atom are 5. Here, the 6th number of electrons are given. So this is also a wrong and incorrect option. So the correct option from the given is option A and B. Option B is correct because boron trifluoride has trigonal planar shape and has 3 electron pairs in the valence shell of boron. All other options contain incorrect information regarding the shape and number of electron pairs. So from here, the right option is option B. This is the correct information. Now let's move toward the next MCQs. The next MCQs is the problem question. It states that the volume of vessel is 1.20 into 10 raised power minus 3 meter cube. It contains the pure argon at the pressure of 1 into 10 raised power 5 pascals. The pressure and volumes are given and the temperature is 25 degrees Celsius, which is also given. Under these conditions, it can be assumed that the argon behave as an ideal gas. So, which mass of argon does it contains? We need to find the mass of argon. To find the mass of argon contained in a vessel, we need to use the ideal gas law. PV equals nRT, where the pressure given is 1 into 10 raised power 5 pascals. Volume is 1.20 into 10 raised power minus 3 meter cube. R is the gas constant. Its value is According to the given conditions, we have 8.31 joule per mole per Kelvin, and the temperature in Kelvin, 25 degrees Celsius. When converted into Kelvin, we have 298 Kelvin. We need to find the number of moles of argon. So N equals PV upon RT. Substituting the values, we get 0.0484 mole. Now the molar mass of argon is approximately 40 gram per mole. The mass of argon can be calculated by using the formula M equals N multiplied by M, which is the molar mass. So when we multiply, we get the answer 1.93 grams. So this is the right option, option B. Now let's move toward the next MCQs. The next MCQ states that a student mixed 25.0 centimeter cube of 4 mole per decimeter cube hydrochloric acid with an equal volume of 4 mole per decimeter cube of sodium hydroxide. The initial temperature of both solutions were 15 degrees Celsius. The maximum temperature recorded was 30 degrees Celsius. The heat capacity of the final solution can be assumed as 4.18 joule per Kelvin per gram, and the density of the solution can be assumed as 1 gram per centimeter cube. Using these results, what is the enthalpy change of neutralization of hydrochloric acid? We have 4 different options. So let's solve this. To calculate the enthalpy change of neutralization, we use the formula Q equals mc delta T. M is the mass of solution. C is the specific heat capacity, which is 4.18 joule per gram per Kelvin. Delta T is the change in temperature, which is 30 degrees Celsius minus 15 equals 15 degrees Celsius. Substituting these values and finding the value of Q, we have 3.135 kilojoule. Now calculate the number of moles of hydrochloric acid or sodium hydroxide reacted. N equals C cross V. So 4 mole per decimeter cube multiplied by 0.0250 decimeter cube. So we will have 0.10 mole. Enthalpy change per mole. The formula is delta H equals minus Q upon N. Putting the values, the answer comes out to be minus 31.4 kilojoule per mole. So option B is correct one. This is the correct answer. Now let's move toward the next MCQs, which is MCQs 10. The next MCQ states that nitrogen monoxide is rapidly oxidized to nitrogen dioxide. The reaction is shown. Nitrogen dioxide can then demerize to form dinitrogen tetraoxide. The enthalpy of formation of these two are given. Now they are asking what is the value of standard enthalpy change of the reaction shown. The reaction is also shown. We are given 4 different options. Now let's solve this. We need to find the enthalpy change of the reaction. According to the given data, we have following information given. We need to find the enthalpy change for the reaction shown. First, find the enthalpy change of the formation of 2NO2. By given formula, we have delta H1 equals 2 into enthalpy change of formation of NO2 minus enthalpy change of formation of NO. When we solve it, we have the value minus 114 kilojoule. The second step is dimerization reaction. The total enthalpy change comes out to be minus 172 kilojoule per mole. So that's the answer. Option D is answer. The next MCQs we have is MCQs 11. It states lithium aluminum hydride contains aluminum hydride ions, in which aluminum has the oxidation state of positive 3. Lithium aluminum hydride reacts with water as follows. So this is, in this reaction, each of our 4 water molecules produces 1 hydroxide ion. It does this by losing ion hydrogen ion, which reacts with the lithium aluminum hydride. So they are asking which change in oxidation state or oxidation number occur in this reaction. We have 4 options. As we analyze the reaction, in this reaction, hydrogen in water is in the oxidation state of +1. When hydrogen gas is produced, hydrogen goes from +1 to 0, indicating our reduction. Well, in lithium aluminum hydride, the hydrogen is in -1 oxidation state as part of the hydride ion. When the hydride ion reacts with water, it forms hydrogen. So hydrogen goes from -1 to 0, indicating oxidation. Therefore, the hydrogen both increases and decreases in oxidation number depending on whether it's from water +1 to 0 or hydride -1 to 0. So option C seems to be correct. Option A, Al increases by 1 and hydrogen decreases by 1. Well, Al does not change its oxidation state. It remains +3 throughout this reaction. Option B, hydrogen decreases by 2 and also increases by 1. As we discussed, hydrogen does not decreases by 2. It undergoes both oxidation and reduction. And option D, oxygen decreases by 1 and hydrogen increases by 1. Well, oxygen in water remains at -2. So there is no change in oxidation state. So only the option C is correct. Hydrogen increases by 1 and also decreases by 1. The next MCQ states that vanadium salt is soluble in water and reacts readily with powdered manganese in dilute sulfuric acid. The example reaction is shown on the screen. Which statement about this reaction is correct? We have four options. First option is hydrogen is oxidized in the reaction. Second, manganese is the reducing agent in this reaction. Third, sulfuric acid is the oxidizing agent in this reaction. And fourth, the oxidation state of vanadium changes from +5 to +3. In this reaction, the manganese is oxidized from its elemental form 0 to form Mn positive 2 in MnSO4. This means manganese loses 2 electrons and therefore acts as a reducing agent. So the correct option is B. Manganese is the reducing agent in this reaction. The next MCQ is in which equilibrium will an increase in pressure at constant temperature increases the yield of the product on the right hand side of the equation. The four equations are given as options. So let's analyze all these options one by one. To determine how an increase in pressure affects the equilibrium, we must compare the number of gas molecules on the reactant and product side according to the Le-Chatelier's principle. If the pressure is increased, the equilibrium will shift towards the side with fewer gas molecules. In option A, the reaction has one gas molecule on the right, while the left side has no gas. Increasing pressure will favor the left side, reducing the yield of carbon dioxide gas. And option B, on the left side there are 5 moles of gases, 4 hydrochloric acid and 1 oxygen molecule. While on the right side there are 4 moles of gases, 2 water molecules and 2 chlorine gas molecules. Increasing pressure will favor the side with fewer gas molecules, which is the right side, increasing the yield of the product. The option C we have, there are 2 moles of gases on the both sides. Therefore, an increase in pressure will not affect the yield. Fourth option, there are 4 moles of gases on both sides. So an increase in pressure will not affect the equilibrium. Thus, only the option B is correct. So that's the correct answer. Increasing pressure will favor the side with fewer gas molecules, which is the right side, increasing the yield of the product. The next MCQs we have is MCQs 14. It states, hydrogen iodine is added to evacuated reaction vessel. The vessel is sealed and warmed. A decomposition reaction occurs. Hydrogen and iodine are formed. Some hydrogen iodide remains. When equilibrium is established, the total pressure is 1 20 into 10 raised power 5 pascals. The partial pressure of hydrogen is 4 into 10 raised power 3 pascals. Hydrogen iodide. Hydrogen and iodine are all gases under these conditions. So they are asking what is the value of Kp for the equilibrium at this temperature, assuming the decomposition is forward reaction. So we have 4 different options. In this question, the equilibrium constant at the decomposition of hydrogen iodide is calculated based on the partial pressure of gases at equilibrium. The reaction involved is shown on the screen. The total pressure given as 1.20 into 10 raised power 5 pascals. Partial pressure of hydrogen is 4 into 10 raised power 3 pascal. Since the reaction produces hydrogen and iodine in a 1:1 molar ratio, the partial pressure of iodine will be 4 into 10 raised power 3 pascals. Now, the partial pressure of hydrogen iodide can be calculated as follows. The partial pressure of hydrogen iodide comes out to be 1.12 into 10 raised power 5 pascals. The equilibrium constant Kp for this reaction is expressed as, substituting the value of Kp comes out to be 1.28 into 10 raised power minus 3. Thus, from these given options, option B is correct. 1.28 into 10 raised power minus 3. That's the Kp value. The next question we have is question 15. It states the equation for two reactions are shown, reaction X and reaction Y. The two reactions have similar reaction mechanism. The initial rate of reaction X is greater than that of reaction Y when measured under identical conditions of temperature, pressure, and reactant concentration. So they are asking which statement explains this difference. They have given 3 statements. The question asks about the factors that could explain why the initial reaction of X, which is NOBr, is greater than that of reaction Y, which is NOCl, assuming similar reaction mechanisms. The first statement is the activation energy of reaction X is less than that of reaction Y. This is the correct statement. If the activation energy of reaction X is less than that for reaction Y, reaction X will occur at faster rate under the same conditions. Since activation energy is major factor in determining reaction rate, this explains why the rate of reaction of X is high. So statement 1 is correct. Statement B, the Br-Br bond is weaker than that of Cl-Cl bond. This statement is incorrect. In this reaction, NOBr breaks to form NO and Br2, while in reaction Y, NOCl breaks to form NO and Cl2. The Br-Br bond isn't directly involved in the reaction mechanism. The relative strength of Br-Br versus Cl-Cl does not significantly affect the rate. So this statement is incorrect. The next statement is the higher frequency of collision between the molecules of NOBr occur than between the molecules of NOCl. This statement is also incorrect because the frequency of collision between NOBr and NOCl is unlikely to differ significantly as these are small molecules. And under similar conditions, the collision frequency is expected to be comparable. Thus, statement 1 is best explanation and the correct answer is C. The next question we have is question 16. It states, the diagram shows a Boltzmann distribution of energies in a gas. The gas can take a part in a reaction with an activation energy EA. The gas is maintained at constant temperature. They are asking Which statement is correct? They have given four different options. Option 1, if a catalyst is added, peak P will be lower and energy will move to the left. Well, this statement is incorrect because while energy moves to the left, the peak P does not lower. The energy distribution is unchanged. So this option is incorrect. Option B, if a catalyst is added, peak P will be lower and energy will move to the right. This statement is also incorrect because energy moves to the left, not to the right. The next option is C. If a catalyst is added, peak P will be the same and energy will move to the left. This option seems to be correct. A catalyst provides an alternative reaction pathway with a lower activation energy. This means that activation energy will decrease, move to the left, allowing more molecules to have a sufficient energy to react. However, the distribution of molecular energies remains the same because the temperature does not change. Thus, the peak P stays at the same point. So, option C seems to be correct. Well, the option D is incorrect. It states if a catalyst is added, peak P will be the same and EA will move to the right. So only option C is correct. This is the correct option. Now the next question states that L, M and N are three different elements from period 3 of the periodic table. L is the element whose atoms have 3 unpaired electrons in its 3p subshell. M is the element with the highest electrical conductivity in the period. N is the element with the highest melting point in the period. So, which statement about the element L is correct? We have four different options. Now, element L has 3 unpaired electrons in its 3p subshell. This implies L is phosphorus, as phosphorus atomic number 15 has 3 unpaired electrons in its ground state. Element M has the highest electrical conductivity in the period. Statement 2. This is the characteristics of metal, specifically aluminum, which has the highest electrical conductivity among the elements of period 3. Statement 3. Element N has the highest melting point in the period. Silicon has the highest melting point due to its giant covalent structure. Now, option A, L has the highest atomic number then M and the lower atomic number than N. This statement is incorrect because L, being phosphorus, has the atomic number 15, has the higher atomic number than both M and N. M is 13 and N is 14. Option B, L has a lowest atomic number than M and highest atomic number than N. This statement is also incorrect because L has the atomic number highest than M and N. The next option is L has a lower atomic number than both M and N. This is an incorrect statement because L has higher atomic number than both M and N. Now we have option D. L has the higher atomic number than both M and N. This is a correct statement as phosphorus atomic number 15 has the highest atomic number than both aluminum and silicon. So option D is correct. L has higher atomic number than both M and N. Now the next multiple choice question we have is question 18. In a reaction 1 and 2, X represents an element in period 3. In each reaction, X is forming a product where X is the highest oxidation state. We have these two reactions. Which ratio shows a steady increase from sodium to phosphorus? We have four different options. Element X represents an element in period 3. This reaction represents the formation of product where X reacts with chlorine. Reaction 2. This reaction represents the formation of product where X reacts with oxygen. X is in its highest oxidation state in each reaction. This is the given information. Now, elements in period 3. The elements in period 3 are sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon. Since we are looking for a steady increase from sodium to phosphorus, we will consider only these elements, analyzing highest oxidation state. In reaction 1, the product formed is XYClZ. The ratio Z corresponds to the oxidation state of X when combined with chlorine. In reaction 2, the product formed is XPOQ. The ratio Q corresponds to the oxidation state of X when combined with oxygen. Now, let's have a ratio analysis. For ratio Z, chlorine compound, this shows a steady increase in the Z ratio from sodium to phosphorus. Now, Q, oxygen compounds. This also shows a steady increase in the Q ratio from sodium to phosphorus. So we have the conclusion, both Z and Q ratios show a steady increase in the sodium and phosphorus. So the answer D is correct. Now we have next question, which states sodium, magnesium, aluminum, silicon, and phosphorus are all the elements in period 3 of the periodic table. This is the correct. Three statements about these oxides and chlorides of these elements are given. These are the three statements. First statement is the ironically bonded oxides all react with dilute hydrochloric acid. Second statement is all metal chlorides produce neutral solution when added to water. Third statement is the two most electronegative elements both form covalently bonded chlorides. So they are asking which statement is correct. We have four different options. Statement 1, the ironically bonded oxides all react with dilute hydrochloric acid. Ironically bonded oxides are typically oxides such as sodium oxide, magnesium oxide, aluminum oxide. These oxides generally react with dilute hydrochloric acid to form salts and water. These are the reactions. This statement is correct. Second statement is all metal chlorides produce neutral solutions when added to water. Sodium chloride and magnesium chlorides both produce neutral or near to neutral solutions in water. Aluminum chloride, however, is hydrolyzed in water to produce acidic solutions due to the formation of Al positive 3 ion. So this statement is incorrect because aluminum chloride produces an acidic solution. Third statement is the two most electronegative elements both form covalently bonded chlorides. In period 3, silicon and phosphorus are the most electronegative elements after aluminum. Silicon chloride and or phosphorus pentachloride are both covalent compounds due to the high electronegativity of silicon and phosphorus compared to the metal, sodium, magnesium, and aluminum. So this statement is also correct, as the statement 1 and statement 3 are correct. So from these given options, option C is the correct answer. Statement 1 and statement 3 are correct. The next question we have is question 20. The table compares calcium with barium and calcium carbonate with barium carbonate. So from the given table, which row is correct? We have four different options. Now, first we have is reactivity of elements with water. Barium is more reactive with water than calcium. The reactivity of group 2 elements, alkaline earth metals, increases down the group. This is because the outer electrons are more easily lost due to increasing atomic size and decreasing ionization energy. Therefore, barium is more reactive than calcium. So the answer from A or B, as barium is more reactive than calcium. The next we have is thermal stability of metal carbonates. The thermal stability of group 2 elements, metals, carbonates also increases down the group. This is because large cations like barium have the lower charge density, which means they polarize the carbonate ion less, making it more stable. Hence, barium carbonate is more stable than calcium carbonate. So, barium carbonate is more stable. Barium is more reactive and barium carbonate is more stable. So, from this, option A is correct. The next question we have is question 21. It states solutions P and Q each contain a different group 2 ion at the same concentration. One contains Mg positive 2 and other contains Ba positive 2. Tests are carried out on separate 5 cm cube samples of P and Q. So these are two different tests. In test 1, add 1 centimeter cube of 0.1 mole per decimeter cube Na2SO4 aqueous solution. And in test 2, add 1 centimeter cube of 0.1 mole per decimeter cube sodium hydroxide aqueous solution. So they are asking what are the results of these tests. This is the result of test 1 and this is the result of test 2. We have two different tables and four different options. Addition of Na2SO4. When Na2SO4 is added, it reacts with beryllium to form beryllium sulfate BaSO4, which is highly insoluble in water and precipitates readily. MgSO4 on the other hand is more soluble, so fewer Mg positive 2 ions will form a precipitate. Therefore, more precipitate forms with Ba positive 2. In test 2, addition of sodium hydroxide. When sodium hydroxide is added, it reacts with beryllium and magnesium ions. However, magnesium hydroxide is less soluble and forms a precipitate more readily than beryllium hydroxide, which is more soluble. Thus, more precipitates form with magnesium in this test. So from these given options, option B is correct. In test 1, more precipitates of beryllium ion, and in test 2, more precipitates of magnesium ion. So option B is correct. The next MCQ states that J dissolves in water to give an aqueous solution K. K gives a dense white precipitate when aqueous silver nitrate is added. When heated with aqueous potassium hydroxide, K gives off a gas that turns moist universal indicator paper blue. So what is J? We have four different options. Let's analyze each statement. First statement is J dissolves in water to give an aqueous solution K. This suggests that J is soluble in water, forming an ionic solution K. Second statement is K gives a dense white precipitate when aqueous silver nitrate is added. As we know, the silver nitrate AgNO3 is used to test for halide ions. A dense white precipitate indicates the presence of chloride ions, as AgCl is a dense white precipitate. Third statement, when heated with an aqueous potassium hydroxide, K gives off gas that turns moist universal indicator paper blue. This observation indicates the production of ammonia gas. Ammonia chloride is an only compound from the given options that dissolves in water to form an aqueous solution, contain chloride ions which reacts with silver nitrate to form a white precipitate of silver chloride. On heating with potassium hydroxide, it undergoes a reaction to produce ammonia gas. Thus, the correct answer is A, ammonium chloride. Our next question is question 23. Ammonium sulfate and ammonium nitrate are used as fertilizers. These salts have different percentage by mass of nitrogen. They have the same effect as each other on the pH of wet neutral soil. So they are asking which row is correct. We have four options. In first table we have higher percentage of nitrogen by mass. And second table shows effect on pH of soil. The first compound is ammonium sulfate. Ammonium sulfate, the molar mass of ammonium sulfate is 132 gram per mole. It contains 2 ammonium ions. The molar mass of nitrogen per formula unit is 2 into 14, 28 gram per mole. So the percentage of nitrogen is 21.2%. The second compound is ammonium nitrate. This compound molar mass is 80 gram per mole. It contains 1 ammonium ion and 1 nitrate ion. The molar mass of nitrogen per formula unit is 2 into 14 equals 28 gram per mole. Percentage of nitrogen comes out to be 35. Therefore, the ammonium nitrate has higher percentage of nitrogen by mass compared to ammonium sulfate. So ammonium nitrate is correct by first statement. Now let's have a look at effect on pH of soil. Both ammonium sulfate and ammonium nitrate are used as fertilizers and they both contain the ammonium ion. When ammonium salt are added to soil, the ammonium ion undergoes nitrification by soil bacteria, converting it to nitrate. This process produces hydrogen ions, which lowers the pH of soil, making it more acidic. Therefore, both ammonium sulfate and ammonium nitrate decreases the pH of wet neutral soil. Our answer is A. Ammonium nitrate effect on pH of soil is decreasing. So that's the answer. The next question we have is question 24. The equation shows a reaction that occurs between carbon monoxide and nitrogen monoxide in a catalytic converter. The reaction is shown on the screen. So they are asking which statement is correct. They have provided 4 statements. Statement 1, the catalyst used is finely divided iron. This is the incorrect statement. The catalyst typically used in catalytic converter is a combination of platinum, palladium or rhodium, not iron. So this statement is incorrect. Second statement, the reaction prevents greenhouse gas emission into the atmosphere. This statement is also incorrect. The reaction reduces carbon monoxide gas and nitrogen monoxide gas, but carbon dioxide gas is still emitted. Carbon dioxide gas is a greenhouse gas. So this statement is not fully correct. The third statement, the reaction reduces the possibility of the formation of photochemical smoke. This is the correct statement. Nitrogen monoxide is a key component in the formation of photochemical smoke, and converting it to nitrogen gas helps reduces this environmental issue. So this statement is correct. Fourth statement, the reaction results in increased ozone depletion. This statement is incorrect, as the reaction has no direct effect on ozone depletion. Thus the correct answer is C. The reaction reduces the possibility of the formation of photochemical smoke. The next MCQ states that which compound has molecular formula C6H10O. We have 4 options. The given molecular formula C6H10O, to determine which compound matches this molecular formula, we need to count the number of carbon, hydrogen and oxygen atoms in each of the compound. Well, this option 1. The structure shows a 5-membered ring with a carbonyl group. This is a carbonyl group. The number of atoms are 6. 6 carbon atoms, 10 hydrogen atom and 1 oxygen atom. So molecular formula C6H10O, this matches the given formula. Option B. Structure shows a ketone group, which is a branched carbon skeleton. Number of atoms 6, 12 hydrogen atoms and 1 oxygen atom. So the molecular formula is C6H12O. This does not matches the given formula. So this is the wrong option. The next formula we have is option C. Structure shows a 6-membered ring with a carbonyl group. The number of atoms 6 carbon atoms and 8 hydrogen atoms and 1 oxygen atom. The molecular formula is C6H8O. This does not matches the given formula. So this is also a wrong option. The next option we have is option D. Structure shows an alcohol group and a double bond. 6 carbon atoms, 10 hydrogen atoms, and 1 oxygen atom. The molecular formula is C6H10O. Thus, the correct answer is A, as it matches the molecular formula C6H10O. So, this is the correct option. The next MCQs we have is MCQs 26. It states the general formula of non-cyclic alcohol is as shown. This is the general formula. So they are asking how many different structural isomers are there for n equals 3 and n equals 4. So we have 4 different options. For a non-cyclic alcohol, the number of structural isomers depends on how the hydroxyl group is positioned on the carbon chain and how branching occurs. For n equals 3, we have C3H7OH. There are 2 possible structural isomers. Propane 1-ol, the hydroxyl group is attached to the first carbon atom, and propane 2-ol, the hydroxyl group is attached to the second carbon atom. Similarly, for n equals 4, we have formula C4H9OH. There are 4 possible structural isomers. First we have is butane 1-ol. The hydroxyl group is attached to the first carbon atom. Second, butane 2-ol. The hydroxyl group is attached to the second carbon atom. And third, 2-methyl propane 1-ol. The hydroxyl group is attached to the first carbon of a branched chain. And fourth, 2-methyl propane 2-ol. In this, the hydroxyl group is attached to the second carbon of a branched chain. So from these given options, option B is correct. As for n equals 3, we have 2 isomers, and for n equals 4, we have 4 isomers. So this is the correct option. The next MCQs we have is MCQs 27. It states compound X. The molecular formula is given. C5H10O3 has 1 chiral carbon atom per molecule. Compound X produces bubbles with Na, but not with Na2CO3. So they are asking which formula could represent compound X. This option, this compound has an ester group and an alcohol group attached to a carbon atom. However, this compound has no chiral carbon because the carbon with the OH group is bounded to 2 identical CH3 groups, making it achiral. So this option is wrong. Option B, this compound contains ester group and an alcohol group. The carbon bonded to CH3 and CH2OH group is chiral, and it is bounded to 4 different groups. The ester group is not acidic enough to react with Na2CO3, but the alcohol group will react with Na, producing bubbles. So this is our required answer. Option C, this compound contains the alcohol group and carboxylic acid. The carboxylic acid will react with Na2CO3, which is not consistent with the information given in this question. So this is the wrong option. Option 4, this compound contains both an alcohol group and carboxylic acid. The carboxylic acid will react with Na2CO3, which is not consistent with the information given in this question. So this is also wrong. The only option which is correct is B, as it contains 1 chiral carbon, reacts with sodium, producing bubbles, and does not react with sodium carbonate. So this is the correct information, and this is the correct option. Now we have question 28. Ethane reacts with an excess of chlorine in the presence of ultraviolet light to form a mixture of products. They are asking how many of these products contain 2 carbon atoms and 1 or more chlorine atoms. We have 4 different options. When ethane reacts with excess chlorine in the presence of ultraviolet light, a free radical substitution reaction occurs, replacing hydrogen atoms with chlorine atoms. The products formed contain 2 carbon atoms with 1 or more chlorine atoms substituted. Let's determine all the possible products that contain two carbon atoms and one or more chlorine atoms. The first we have is monochlorinated product. Only one possible product, no isomer. The structure is shown on the screen. The second we have is dichlorinated products. In dichlorinated products, we have 1,2-dichloroethane, 2 chlorine on same carbon, or 1,2-dichloroethane, 1 chlorine on each carbon atom. The third we have is trichlorinated products. In trichlorinated products, 1,1,1-trichloroethane, 3 chlorines on 1 carbon. The second we have is 1,1,2-trichloroethane, 2 chlorines on 1 carbon and 1 on the other. The third we have is 1,2,2-trichloroethane, 1 chlorine on 1 carbon and 2 chlorines on the other. The total trichlorinated products are 3. As you see, 1,1,2-trichloroethane and 1,2,2-trichloroethane are same, and these two are isomers. So we will use one from them. So total trichlorinated products become 2. The next we have is tetrachlorinated products. In tetrachlorinated products, we have 1,1,1,2-tetrachloroethane. In this, we have 3 chlorines on 1 carbon, 1 on the other. The second we have is 1,1,2,2-tetrachloroethane. In this, we have 2 chlorines on each carbon. So total products in tetrachlorinated products we have 2. Next we have is pentachlorinated products. Pentachlorinated product has only one product, which is 1,1,1,2,2-pentachloroethane. The formula is shown on the screen. So it's only one product. The last we have is hexachlorinated product. In this we have hexachloroethane, C2Cl6, one product. From this, the summary of the product is as shown on the screen. From these listed trichloroethane, we are using only 2 products, 1,1,1-trichloroethane and 1,1,2-trichloroethane. As they are isomers, so we are skipping 1,2,2-trichloroethane. Therefore, the total number of products that contain 2 carbon atoms and 1 or more chlorine atoms is 9. Thus, the correct answer is D. This is the right answer. The next question we have is question 29. When bromoethane reacts with hot ethanoic sodium hydroxide, a colorless gas is formed. This gas decolorises aqueous bromine. So they are asking, what is this colorless gas? We have 4 different options. When bromoethane reacts with hot ethanoic sodium hydroxide, it undergoes an elimination reaction. This results the formation of ethene, C2H4, a colorless gas. The reaction is shown on the screen. So from these given options, the option C is correct. The next question we have is question 30. It states, alkynes are hydrocarbons that contain one triple bond. Like alkenes, alkynes take part in addition reactions. A saturated compound can be formed. For example, ethyne reacts with an excess of hydrogen to form ethane. Propyne undergoes an addition reaction with an excess of hydrogen bromide in 2 stages. Markovnikov rule applies to the addition of hydrogen bromide at each stage. So they are asking, what is the main product obtained when propyne react with an excess of hydrogen bromide? We have 4 different options. Propine has a formula CH triple bond C bond CH3. When propine reacts with an excess of hydrogen bromide, an addition reaction occurs in two stages following Markovnikov rule. Markovnikov rule states that the hydrogen atom from hydrogen bromide will add to the carbon atom of the triple bond that already has more hydrogen atoms. So from propane, this is the carbon which has more hydrogen atoms. So the hydrogen will add here and bromide will add here, and the triple bond will get broken. So the next we have is CH2 double bond CBr bond CH3. This is a stage 1 reaction. In the second stage we will have CH3 bond CBr2 bond CH3. This is according to the Markovnikov rule. So from these given options, option D is correct. That's our answer. The next MCQ states that bromine reacts with alkene by an electrophilic addition mechanism in which a cation is formed as an intermediate. So they are asking which mixture will produce most stable intermediate cation. They have given 4 different options. As we know, the bromine reacts with alkane via an electrophilic addition mechanism. During this mechanism, the carbocation intermediate is formed. The stability of this intermediate is crucial to the rate of the reaction. The stability of the carbocation increases as follows. Tertiary greater than secondary, which is greater than primary, and which is greater than methyl. So let's analyze all these options. First option is 3,3-dimethyl pent-1-ene plus bromine. The double bond is attached to the primary carbon and the intermediate formed would not be as stable as those from more substituted alkenes. So this is incorrect. Second option is ethene plus bromine. In this option, ethene forms a primary carbocation, which is the least stable. As you see, the stability of the carbocation increases in the following order. So this option is also wrong. The next option is methyl propene plus bromine. In this option, methyl propine forms a tertiary carbocation due to the methyl groups stabilizing the positive charge through inductive and hyperjunction effect, making it the most stable intermediate. Option D, propine plus bromine. Propine forms a secondary carbocation, which is less stable than a tertiary carbocation. Therefore, the mixture that will produce the most stable intermediate cation is C, methylpropine plus bromine, as the intermediate is the tertiary carbocation. So this option is correct. Option C. The next question we have is question 32. It states that halogen alkanes react with hot ethanoic potassium cyanide. The reaction mechanism is either SN1 and SN2. So they are asking which statement is correct. Let's analyze all options. The first option is all secondary halogen alkanes react by SN2 mechanism only. This is the incorrect statement because secondary halogen alkanes can react by either SN1 and SN2 depending on conditions. So this is incorrect. The second statement is both the halogen alkanes and the cyanide ions are involved in the initial step of the SN1 mechanism. In SN1 mechanism, the initial step involves the halogen alkanes ionizing to form a carbocation. The cyanide ion does not participate in the initial step, making this statement incorrect. So option B is also incorrect. Now the next option, option C. Chloroethane react with cyanide ion by the SN1 mechanism only. Chloroethane is a primary halogen alkanes, and the primary halogen alkanes typically react by SN2 mechanism, not SN1. So this statement is also wrong. Option D, SN2 mechanism involves the short-lived negatively charged transition state. This is a correct option, as in SN2 mechanism a negatively charged transition state is formed where the nucleophile and the leaving group are partially bonded to the carbon atom. So option D is correct. Question 33. X, Y and Z are three isomeric alcohols. Separate samples of each alcohol are warmed with the mild oxidizing agents and the results noted. One of these alcohols, when dehydrated, will give a pair of cis-trans isomers with molecular formula C5H10. So they are asking which row is correct. Now let's analyze each alcohol. First, X. This structure represents a primary alcohol. It can be oxidized by a mild oxidizing agent to an aldehyde and subsequently to a carboxylic acid. When dehydrated, a primary alcohol gives an alkene. However, with 5 carbons, this will produce a terminal alkenes, which does not have cis-trans isomerism. Alcohol Y, this structure represents a secondary alcohol. It can be oxidized by mild oxidizing agent to a keton. When this alcohol is dehydrated, the resulting product is 2-pentene, which can exhibit cis-trans isomerism. Alcohol Z. This structure represents a tertiary alcohol. Tertiary alcohols are not easily oxidized by mild oxidizing agents due to the absence of a hydrogen atom on the carbon bonded to the hydroxyl group. When dehydrated, a tertiary alcohol will give an alkene, but in this case, the product will be 2-methylbutene, which also does not exhibit cis-trans isomerism. So now let's analyze the answer. First we have the table which reacts with mild oxidizing agent. X and Y can react with mild oxidizing agents, but Z, a tertiary alcohol, cannot. And the second table gives cis-trans isomerism. Only Y, when dehydrated, gives an alkene, which is 2-pentene, with a cis-trans isomerism. Thus the correct option is C. The next question we have is question 34. It states, compound G gives a pale yellow precipitate with alkaline I2 aqueous solution. So they are asking, what could be compound G? This question relates the iodoform test, which is used to detect the compounds that contain a group, which is secondary alcohol, and this group, which is methyl ketone. These two compounds, when these groups are present, they react with iodine in an alkaline solution, producing a pale yellow precipitate of iodoform test. So from these given options, option B seems to be correct. Pentane 2-ol. It contains CH3CH double bond OH group. When oxidized, it forms methyl ketone pentane 2,1, which gives positive iodoform test, resulting in the yellow precipitate. Option A is incorrect, as pentane 1-ol does not contain the group CH3CH bracket OH and cannot form a methyl ketone. Therefore, it does not give a positive iodoform test. Similarly, option C and option D. Option C lacks the group, thus it does not give the positive iodoform test. And option D is a tertiary alcohol, and it also does not give the required iodoform positive test. So only option B is correct. The next question we have is question 35. The mechanism of the reaction shown between ethanol and hydrogen cyanide starts with the step shown. So they are asking, what is the correct structure of the intermediate ion formed, and what is the next step in this mechanism? The mechanism for this reaction between the ethanol and hydrogen cyanide is shown. Cyanide ion act as a nucleophile. In the first step, The cyanide ion attacks the carbonyl group of ethanol. The cyanide ion donates the electron pair to the carbonyl carbon, making the carbon more electron rich. The electron pair from the cyanide breaks the carbon-oxygen double bond, pushing the electron onto the oxygen atom. The negatively charged oxygen attracts the proton, most likely from the proton donor, hydrogen cyanide or water, to neutralize the charge, completing the reaction. Here, from these four, A and C are incorrect. Option B and option D look similar, but look here. Double bond and triple bond. So option D is correct. Option A and C, these structures shows the positively charged oxygen, which is incorrect for the nucleophilic addition mechanism. Option D is correct answer, showing the appropriate intermediate ion and the correct next step in the mechanism. The next question we have is question 36. It says, which compound reacts with 2,4-dinitrophenyl hydrazine reagent but does not react with Tollens reagent? We have four options. Now, what is 2,4-dinitrophenyl hydrazine test? Dinitrophenyl hydrazine reacts with carbonyl compounds like aldehydes and ketones to form hydrazone, which is usually a precipitate. Therefore, both aldehydes and ketone will give a positive test. Now, Tollens reagent test. Tollens reagents specifically reacts with aldehydes to form a silver mirror, but it does not react with ketones. This test distinguishes between aldehydes and ketones. Now let's analyze all these options. The first option we have is acid. It contains a ketone group and carboxylic acid group. The ketone group will react with dinitrophenyl hydrazine, but the carboxylic acid will not react with Tollens reagents. Option B, this is an aldehyde with a phenol group. This compound contains an aldehyde group which will react with both 2,4-dinitrophenyl hydrazine and Tollens reagents. Therefore, this option is not correct. Option C is acetone. Acetone is a ketone and does not have an aldehyde group. However, it is an hydroxyl group. The Tollens reagents might not react, but dinitrophenyl hydrazine will react. But it's not as suitable as option A for non-reactivity with Tollens reagent. The next we have our secondary alcohol. This is an alcohol and does not contain carbonyl group, so it will not react with dinitrophenyl hydrazine. Thus, the correct option is option A. This acid reacts with dinitrophenyl hydrazine due to the ketone group, but it does not react with Tollens reagents. So this is the correct option. The next question states that compound X has stereoisomerisms and form a precipitate when warmed with fillings reagent. So they are asking what could be the structure of compound X. We have four different options. What is stereoisomerism? Stereoisomerism suggests that the compound must have geometric cis-trans isomerism or chiral center. Reactions with fillings reagent. Fillings reagent is used to test the presence of aldehyde except aromatic aldehydes. Ketones generally do not react with filling reagent except for alpha hydroxy ketones. Option A. This compound has alpha beta unsaturated aldehyde. It has a double bond and an aldehyde group, which means it could form a precipitate with fillings reagent. However, it does not exhibit stereoisomerism. This option B, this compound is conjugated ketone with two double bonds but it does not have an aldehyde group, so it will not react with Filling's reagent. Option C. This is a keton. Keton do not react with Filling reagents. So this option is incorrect. Option D. This is an aldehyde with chiral center, since it has 4 different groups attached to the carbon atom. It will react with Filling's reagents, and it also has stereoisomerism. So from these options, option D is correct. This is an aldehyde with chiral center. It will react with Filling reagent, and it also has stereoisomerism. The next question we have is question 38. It states which reaction will form propanoic acid. Option 1, acidic hydrolysis of propanyl ethanoate. Propanyl ethanoate is an ester formed from ethanoic acid and propanol. Its hydrolysis will not yield propanoic acid, but rather ethanoic acid and propanol. So this option is incorrect. Option B, alkaline hydrolysis of ethyl propanoate. Ethyl propanoate is an ester formed from propanoic acid and ethanol. Alkaline hydrolysis of this ester will produce propanoate salt and ethanol. However, converting the propanoate salt to propanoic acid requires further acidification. So this is incorrect, since it requires extra steps. Option C, acidic hydrolysis of propanenitrile. Propanenitrile is an organic nitrile compound. Acidic hydrolysis of nitrile results in the formation of carboxylic acid corresponding to the carbon chain. Thus, propanenitrile will yield propanoic acid. So this is the correct option. Option D, acidic hydrolysis of ethane nitrile. Ethane nitrile is a nitrile that will form ethanoic acid on hydrolysis, not propanoic acid. So this is an incorrect option. So option C is correct. Acidic hydrolysis of propane nitrile. The next question we have is question 39. It states lactide is an intermediate in the manufacture of synthetic fiber. So they are asking which compound on heating with the acidic catalyst can produce lactide. They have given 4 different options. Lactide is a cyclic diester formed from 2 molecules of lactic acid known as 2-hydroxypropanoic acid. The first option is hydroxyethanoic acid. Hydroxyethanoic acid has 2 carbons and cannot form a 6-membered cyclic diester structure seen in lactide. So this option is incorrect. Option B, 2-hydroxybutanoic acid. This option is also incorrect, as 2-hydroxybutanoic acid has 4 carbons, and the esterification of this compound would lead to a different structure than lactide. The next option is option 3, 2-hydroxypropanoic acid. This is a correct option. 2-hydroxypropanoic acid is capable of forming lactide through the reaction between 2 molecules. The reaction involves dehydration and cyclization, leading to the formation of the 6-membered cyclic diester. Option D is 3-hydroxypropanoic acid. This is also incorrect, as 3-hydroxypropanoic acid would form a different type of polymer, as the hydroxyl group is on the 3rd carbon, preventing the formation of lactide structure. Thus, the correct option is C, 2-hydroxypropanoic acid. The next question we have is question 40. It says, the diagram shows the relative abundance of different isotopes of lead in a sample of lead ore. The abundance of 208 is half that of 206, and the abundance of 208 and 209 are equal. So this is half and this is equal. Let's solve this here. Abundance of 206 is 50. So 50 multiplied by 206 plus the abundance of 208 is 25. Similarly, let's divide them with 100. Now the answer comes out to be 207.25. So option B is correct answer.